Oh, let's not do a highlight. Let's change it to something else. That's fine. Number 63.
Yes.
And we have a w over w minus z over z minus w. Now, there are going to be two paths you can take on this. Let's just do the straightforward one. Are those the same denominator?
No.
No. In order to subtract fractions, what do you need? Common denominator, right? So let's do it the first method, which might be a little longer than the method some of you used. What are you going to multiply this one by right here?
Z minus W
Over z minus w. And what do you multiply this one by?
W minus Z over W.
Correct. So now what is the, do we have a common denominator now?
Yes. Yeah.
We do have a common denominator now. That's the same thing in both fractions. So now we just have the same, we subtract the numerator, so you have w minus z minus w minus z times w minus z over, what's the common denominator?
W minus Z.
W minus z. Now the thing is, you're not done at this point because it's asking you to add or subtract. Also, I think you want to simplify when you can.
W and W minus Z. It's not
Oh, did I write it twice? I did. So it's z minus w. That is not the correct. Z minus w, right? Like this? So at this point, you want to, what should you do now to try to simplify? Distribute on the top. Correct. Yeah. Remember, don't multiply out the bottom unless you absolutely have to. Don't multiply out the bottom unless you absolutely have to. And you do not have to at this point. Multiply out the top, and what do you end up with? WZ minus what?
Z squared.
W squared minus ZW plus what? Z squared, all over the same thing. W minus. Takes 2 seconds to write it out. Please write it out. Anything cancel on top? Yeah, something cancels. What cancels? These cancel, right? Correct? So let's rearrange that. What's that on top? That's going to be Z squared minus what? Over. Same thing right here, right? W minus Z over Z minus W, right? What do you see on top? What do you see on the numerator? Yes, you see difference of squares. Can you tell me what that factors into, Hannah?
Z plus W and Z minus W.
Correct, exactly. Over what? W minus Z, Z minus W. What cancels? What cancels? Z minus W. So what are you left with? Z plus W over W minus Z. That would be the final correct answer. Is there another path? Yes, but I'm going to do that one first. There is another path which is shorter. I just wanted to do the one that's most traditional, okay? There's a shorter path that you can do, but only if you recognize something really important first. And generally speaking, you might not see this. So does this make sense? So are each, is the numerator as simplified as it can get? Is the denominator as simplified as it can get? So this equals the numerator times the reciprocal of the denominator, which is what? X over 6. What's the only thing that cancels at this point right here? What's the only thing that cancels? The 6 and the 12. This and this cancel. What's left up top? 2. So what do you end up with? 2x over. Is there anything you can do at that point? No, you stop there. Can you cancel the x? No, why not? Because there's a minus in the bottom. It's not all multiplication. It does not cancel. Do not do that canceling. Don't do that. Please don't. Don't. Separately, is there anything you can do to simplify the numerator or denominator here? There's no factoring to be done. There's no canceling. So this equals 1 minus r over 4r times what? 8r over 1 plus r. Now what cancels here? 8 and 4. This cancels, leaving you with 2. And what else cancels? There's one more thing that cancels. Well, just this one right here. Those r's cancel right there. So what are you left with? 2 times 1 minus r over what? 1 plus r. Is there any canceling you can do at this point? No, you could multiply with the 2 and the r, but there's nothing else to do at this point. There's nothing else to do. Yes, Chris?
So on the test, would you want us to distribute? Like
No, leave it like that. I prefer, like, of the two, it's not going to make that big of a difference. I like it like this in factored form because factored form allows me to see your thought processes a lot more clearly than if you multiply it out. That becomes much more, that difference becomes much more sharp later when you have bigger things that are factored. For example, if you, later we might factor something that is a cubic and we might end up with something like this. If I see the 3 factors, I'm like, oh, you have the 3 factors. If you multiply it out, that's a cubic, and there's a lot of things you can do wrong there. So no, I would rather you have it in like that form. That being said, if for some reason I gave you a multiple choice question, you might be forced to multiply it out for some reason. But as I told you before, don't multiply things out unless you have to. You like things to cancel. Things cancel when they're factored. So when things are in factored form, you're like, yay, I might be able to cancel something. Once you multiply it out, it's kind of like the Wild West. You have to be very careful about it. we're adding in equations with rational expressions and graphs. So this right here, none of the pieces on this one, are any of those pieces new? No. But the new thing is, what have I added in? An equal sign. So these, what are we doing with these? One word. What's the action we're doing? We're going to be solving. Solving for? X. We are solving for X. We are solving for X. So let's just look at the left hand. This is just the left hand expression. What do you think you have to do first to the left? Yes, Chris?
Yeah, at least common denominator.
Well, you find the least common denominator so that you can then do what?
Solve. Well,
Solve is our goal. So what's between finding a least common denominator and solving? What's next?
simplify.
Simplify. Before we simplify, what do we have to do on the left? Yeah.
Like getting the least common denominator.
What do we do once we have the least common denominator on the left?
Add X
by
by
the
itself.
X by itself will be eventually what we do. What do we do on the left? What's that operation called? Subtraction. So to do subtraction, what do we need to do? What do we need to have? We have to have a common denominator so that we can actually create one fraction on the left. Create one fraction on the left. So the steps are, first, actually before we do anything, it's important. I always forget this personally. I always go back, but it's great if you do it first. The first thing you should do is figure out what the domain is. Can someone tell me the domain of that equality right there? It's all real numbers except what? X such that X can't be 0. Why can't X be 0? It's doubly true, right?
Because 2 times 0.
Because 2 times 0.
No.
I need more. I need more.
The 0 can't be in the denominator.
Yeah, exactly. So you can't put it there or there, right? So it really isn't in the denominator. Okay. So then there are all these steps down here. Multiply each side by the equation by the LCD. So there's two ways to go about it. There's two ways to go about it. We have a bunch of fractions. So effectively what they're telling you to do right there, get rid of them. So for example, if let's say I had 1/2 plus 1/3 plus 1/7 equals X. Let's say I gave you that right there, for example. If I wanted to get rid of all the fractions right there, what could I multiply both sides by? What should I multiply both sides by? Okay, I'll make it simpler for you. What happens if, for example, I had 1/2 equals X? What do you multiply both sides by? 2. What happens if I had this? What do I multiply both sides by? Y, 6.
It's 3 times 2.
3 times 2. What happens if I have that?
42.
42. How did you get 42?
The least common.
It's the least common denominator, right? So what they ask you to do, which I think is a great first step, not just combining the fractions, which is what I would do, but here's a better way, I think. We multiply everything by the LCD. What's the least common denominator on this one?
42.
On this one right here. Nope. 2x. 2x is the least common denominator. So we need to multiply everything by 2x. So it's 2x times 2 over x minus 2x times 3 over 2 equals 7 times, sorry, what is 7? 2x, sorry, excuse me. 2x times what? Now why did we do that? What should theoretically happen when we do this multiplication? Yeah.
You should have one fraction left side.
We should have we should have actually no, well,
I mean, like,
what happens to all the denominators?
big capital.
Yeah, so can you tell me on this one, on the first product right here, what cancels on the first one? The x goes away, right? What cancels over here? 2, and then what cancels? Both of them. So what's left? Can you tell me what's left? Someone raise their hand. Monica, what's left? 4 minus? Yeah. Any fractions left? No, when you multiply by the LCD, what should happen? All the fractions should go away. So what do we subtract from both sides? Negative 3x equals 3. So what does x equal? Negative 1. Look at that. We just solved our first rational expression. Let's look at this one right here. This one looks a lot worse. Is it?
No.
Not really. Tell me what the LCD is. Can someone tell me what the LCD is on this one? Be careful. Hannah, what's the LCD?
X squared minus x.
It is. What's the factored form of that?
X minus 3 and x plus 3.
Yes. When you have the choice, write the LCD as the factored form because it's easier to cancel that way. That is the LCD. It's easier to see because what is this factored right there? You already just told me. What is that factored?
X minus 3x plus 3.
Yeah, when you find the LCD, one thing that's going to be helpful is going to be factoring everything first. So that is the LCD. So what happens when you multiply everything by the LCD? What does the first term become? Raise your hand when you have that. What does the first term become when you multiply by the LCD? Noah?
X minus 3 squared.
Nope. What does it become? Simple. I want you to do it in one step for me. When you multiply, you're multiplying everything by this. So when you multiply this by what's in there, what do you get?
Oh, you get 2
2 times.
x minus 3 times x plus 3.
Okay, we're going to do it out then. Okay, you can't see it. 2 times x plus 3. Exactly.
Oh, okay.
Thank you. The x minus 3 cancels. Exactly. You see that, everybody? What about this next one? Minus 3 times what? Minus 3, because that's the one that's left, because the x plus 3 cancels. And what does it equal? 12. Is that a lot easier to solve? When you multiply by the LCD, it should nuke all of the denominators. And then you have something that's just a straight monolined equation. There's no fractions in there. So you get 2x plus 6 minus 3x plus 9 is equal to 12. What do we get? How many x's on the left? Negative x of them, I think. Plus, what, 15 is equal to 12? What do I subtract from both sides? So what does x equal? 1. It's kind of cool. What should you do if you have time? Check your answer, yeah.
Oh, I know. It equals 3.
It equals,
Yeah.
why did I write that? What am I doing?
I said it.
What am I doing? You said it, I said it, I'm like, that's totally not true. There's a famous economics professor who, in his college economics course, Sarah, he would do one of the things he would do every day, and in each of his lectures, he would build in one lie. In each of his lectures, he would build in one lie. Like, he'd define something like the opposite of how it should be defined. But he would tell kids every day, like, I'm going to work something in. He actually didn't need to state it. And what was one of the things the kids were trying to figure out? What the lie was, right? It's really hard. I was like, how could I apply that math? The problem with that is, just by being human, we all make kind of mistakes on things. Like, is he lying to us? Or is that true? You know what I mean? Like, we doubt everything. We would totally doubt everything. You already had the one line. This has to be true. 7 plus 5 is a billion. Yay! I have invented infinite energy. Okay. Okay, get up to the board. Do this one on the board with somebody else. I'm multiplying by the same thing, like a over a. You're not multiplying by the LCD over the LCD. You're multiplying by the LCD, which is LCD of this is what?
3x
X times 3x. Kids, you need to stop. X times 3x plus 1. And then you multiply each individual term by that. So in the big red up there, that's great. When you do that multiplication, a bunch of stuff cancels. What happens to the first term when you multiply by the LCD? What cancels? 3x plus 1, leaving you with just 2x. What happens in the second term? The x cancels, leaving you with 1 times.
3x plus 1.
And the next one is minus, the 3x plus 1 cancels 6x times x. So you now have 2x equals 3x plus 1 minus 6x squared. What type of equation is this? Yes.
The quadratic.
Quadratic. What's the first step?
You have
Set it to 0.
Set it to 0. So let's simplify a little bit. So 0 is going to be x plus 1 minus 6x squared. I subtracted 2x from both sides. Hannah, I subtracted 2x. Is that the proper order of the terms, though?
No.
No. I like writing it as negative 6x squared
Plus 1. Or
plus x plus 1 is equal to 0. And now, what's the verb? Begins with an F that you've done so many times. Factor. Do I like having a negative in front?
No.
So what could I factor out first, Chris?
The negative.
I could factor out a negative and turn it into 6x squared minus x minus 1 is equal to 0. I like that because it makes it easier for me to factor. Makes it easier for me to factor. Then you just have to factor it properly. If you factor it properly, you're going to end up with 3x something and 2x something, I think. Or is it 6?
Yeah, it's
3x, right?
3x.
It's going to be 3x, I think, plus 1
Yeah.
and 2x minus 1.
because then they both turn.
3x squared, and you get and then you get negative, and then you plus. That works. So can someone tell me what the or statement is right now? Someone who hasn't spoken yet. Someone who hasn't spoken. Come on. Fitch, yeah.
2x plus 1
Yep.
equals 0.
Or,
2x minus 1 equals 0.
which are relatively straightforward, right? So 3x equals negative 1. X is equal to negative 1/3. 2x is equal to 1, so x is equal to 1/2. The negative doesn't matter because it's out front. Can this negative, girls, can this negative cause this to be 0? No. Only this or this can be made equal to 0. Only that or that. Now the last thing you have to check, you find the domain first. Let's look at the original function right here. Can you tell me what the domain of this function is right here? It's all real numbers except for x such that x can't be 0 or what? There's one, this is important, girls. Ah, close.
Negative 1.
That can't, x can't be 0 right there, right? But this can't be 0, right? 3x plus 1 can't be 0.
0 times
What
3 plus what?
So-
Negative 1.
Negative what?
1.
Nope.
Negative 3.
Nope.
Negative x.
Stop and think
I am
before.
thinking.
You're not, because there's not even time for you to breathe between your statements, okay? 3x plus 1 can't be 0, so x can't be
Negative 1/3.
negative 1/3. Ah, but what did we get for an answer?
Negative 1/3.
We got two answers here, negative 1/3 and a half. So the actual answer is just what?
1/2.
Just this one. Why? Because this one is not in domain. You have to check that.